Hey guys, and welcome to this class, Data Science, Logistic Regression in Python. In this course, we're going to learn about logistic regression. It is the basic building block of neural networks and deep learning, and so it's essential for understanding more complex machine learning models. I incorporated a lot of feedback into this course, and so I want to talk a little bit about that here. First, let's talk about who this course is for. This is for people who want to go a little bit further than everyday programming, into the realm of becoming a data scientist. In fact, that is why I put data science into the title of this course. So what does this entail? Well, let's talk about what an everyday programmer might do. You are the guy who doesn't really know the math or care for it, and that's okay. You just want to apply the machine learning model and be done with it. This course is not for you. If this is what you want to do, I can do you one better. You can install scikit-learn for Python, and you can have not only logistic regression at your disposal, but also decision trees, random forests, support vector machines, k-nearest neighbors, AdaBoost, and many other algorithms, all with the same API. So to switch between one model and another only requires changing maybe one or a few lines of code. And if that's all you want to do, you don't really need any classes. You just need to know how to program well enough to use APIs and read and understand documentation. Now, if you do want to take the next step and really understand how logistic regression works, what are its nuances, and by extension, how neural networks and deep belief networks work, then this course is for you. And yes, machine learning requires a lot of math. In fact, all the programming you'll do is to just implement the math. So in a way, it's all math. You can't really avoid the math. If you want to avoid the math, then we get back to the everyday programmer situation where you're really just calling an API. So it's up to you to decide how far you want to go. Doing the math is what makes a data scientist a data scientist. Now let's review what this course is going to be about. First, we're going to talk about what is classification and review this in the broader context of all machine learning. Then we're going to talk about linear classifiers in general, of which logistic regression is one example. Then we're going to talk about the biological inspiration for logistic regression, the neuron, and go into some of the older models of the neuron, namely the perceptron. Next, we'll look at how logistic regression can be pictured schematically and how we might extend these schematics to create different kinds of models. Next, we'll look at the feed-forward mechanism of logistic regression and its probabilistic interpretation. Next, we'll look at the cross-entropy error function. And then we'll look at the maximum likelihood function and talk about the broader notion of an objective function. In essence, all machine learning problems try to optimize an objective function. The trouble is, what should be the objective function and how should we optimize it? And that is what we'll cover in the lecture after this one, how we use gradient descent to optimize the logistic regression objective. In the 3 lectures after that, we'll talk more about practical problems and examples surrounding logistic regression, regularization, the donut problem, and the XOR problem.